Okay, welcome back again. So let's actually talk about our project for based on chapter 11. So hopefully it can be captured here on the camera. So this project is on page 810, number 13. And from our previous project, in the previous project we talked about our bank account. So in this particular project, we'll say define the class bank account, which we probably already have. We have defined the bank account in our project number 1. To store a bank customer's account number and balance. Did you have account number and balance? Yep. So suppose that account number is of type integer, not a problem. And the balance is of type double. Definitely, we probably have that. Your class should at least provide the following operations. Set the account. You can set the account. You can ask the user, what's the account number? You can set account number. Retrieve the account. These are just a couple of getters and setters. Retrieve the balance, not a problem. Deposit and withdraw. Were you able to deposit and withdraw? If not, then we can probably do it tonight. We want to make sure that we are able to deposit and withdraw. And print the account information. So we already have this piece. You already have this piece. If not, then hopefully by tonight we'll have that piece up and running. Now in the second part, part B, on page 810, it says every bank offers different types of accounts. A checking account, and hopefully I can highlight it here. A checking account. Derive the class checking account from the class bank account, designing in part. So basically that will be your derived class from the bank account. You have checking account. This class inherits members to store the account number and the balance from the base class. What exactly we are inheriting? We are inheriting the account number and the balance. A customer with a checking account typically receives interest. So not all accounts will receive interest. That's why we need to have inheritance in this place. Maintains a minimum balance and pays service charges if the balance falls below the minimum balance. So these are a couple of new things we have to add to the checking account, which we probably did not have at the bank account level. Add member variables to store this additional information. All we are saying is add some variables. In addition to the operations inherited from the base class, this class should provide the following operations. Set interest rate, really one-line code. Retrieve interest rate, another one-line code. Set minimum balance, not a problem. Retrieve minimum balance, that's your getter. Set service charges, retrieve service charges, post interest rate, verify the balance is less than the minimum balance, write a check. Most of these methods are one-line methods. These are basically setters and getters. And even if before you write the whole thing, you just want to write one of them and see if it works. See if you can actually do the print method, and you can print the checking account information. Now remember, your bank account already has a print method, which displays your account number and balance. So you want to call that one first. Then you want to have something in the local print method of your checking account. So if I were you, if I'm designing this one, I'll stop right there and I'll start developing this one. I will not look at number C. C will be almost identical, but it will refer to savings account. Savings account. So it's basically exactly the same thing. There's some variations because checking is different from savings. It will provide you some other things. It tells you the same thing. A customer with a savings account typically receives interest, makes deposits and withdraws money, in addition to the operation inherited from the base class. This class should provide the following: set interest rate, return. I will actually copy paste. You can easily do that, or just one line code. Post interest rate, withdraw, override the method of the base class, and print information. And then this could be your main function, or you can write another separate class. Like in my case, I wrote a supervisor class. You can write another separate class just to test these checkings and savings. Okay? So the assignment you have, you already have 50% assignment. So I should be getting something from you, something like coffee or something, because I'm not giving you so much work. So it's not too much work because you already developed the first assignment. Now, some of you say, I have not even started the first one. Then yes, it's a lot of work. But if you already have finished the first one, then it should be pretty straightforward. So guys, do not worry about savings first. Just work on checking. Just focus on the bank account and checking. Then once you're satisfied it works, it's providing you the operations, then you can add the savings one. Okay? Now you have two choices. You can actually test your operations in the main function, or you can add another one, call it test bank account. Another separate class just to test it, just like I showed you the supervisor one. And then you can do the initialization or show method in that one. Or just if you want to keep it simple, just test everything. The main reason is the book is highlighting here, write a program to test your class design in parts A and B, or B and C. The main purpose is that main should be the driver function. Main should not have any specified or specific kind of code. Main should be just driving other functions or other classes. But initially, if you just want to test it in the main function, there should not be any problem. You think we can do it? Mm-hmm. Yeah. Okay. All right. That's all we have for tonight. And I just want to highlight one more thing before I forget. I forgot to mention this one when I was doing a demo. Let me go back to my demo just very quickly. This is what I forgot. I'm going to comment this very quickly and uncomment the other one. Here it is. So if I want to access this name directly here, so I would like to access the name directly in my derived class. It's already telling me it's an error. Let's look at the error message. When I run it, the error message is employee name or name declared is inaccessible. It's basically line 11 is inaccessible. So it's basically telling it's a private member. It's a private member, cannot access private member. So just wanted to highlight that one. Now, if I really want to access this one in the derived class, I have to change this to protected member. So I'm going to change that to protected member. And comment out this part here. So what I just did, in my employee class, as you can see on the camera, in the employee class, I made my name or my data variable as protected member. By making it protected, I'm hoping this time the derived class can access it. Let's take a look. So I'm hoping it can access it. Looks like there's no error message here. So this time when I run it, it runs successfully. So that's where you can use the protected identifier. When you use as a protected at the base class, the derived classes, they can see the data. Now that does not mean I can see the name in my main function or some other places. That's not true. It's only visible to within the hierarchy of those classes, within the inheritance. But outside world still cannot see that protected data. Okay? All right. Thank you guys. Good night.